Hello again. In this video called Complex Numbers Part 3, we're going to look at how to multiply and divide complex numbers. Let us begin. Okay, let's look at this example of 2 plus I times 3 plus 2I. Now just like with binomials, we're going to go ahead and use the double distribution. So I'm going to multiply 2 times 3 to get 6. 2 times 2i to get 4i. I times 3 is 3i, and then I times 2i is plus 2i squared. Okay, when I go to combine like terms, I see I have 4i plus 3i, which gives me 7i, so I have 6 plus 7i plus 2i squared. And remember from the previous video that I squared equals -1. So then I'm going to have 6 plus 7i plus 2 times -1. So this becomes -2. 6 plus 7i plus -2. 6 and -2 gives me 4. So I have 4 plus 7i. So one thing that's different than multiplying regular binomials is the fact that there's going to be an extra step, because when you're going to multiply I times I, you get I squared, and then we make the substitution that I squared equals -1. Okay, let's look at this example. We have -8 plus 3i times 5 minus 7i. Okay, I'm going to distribute, so I have -8 times 5, which gives me -40. -8 times -7i gives me positive 56i. And 3i times 5 gives me 15i. And 3i times -7i gives me -21i squared. Add the i's together, so I'll bring down the -40 plus 56 plus 15 gives me 71i. And then this is minus 21i squared. I squared is -1. So I'll have -40 plus 71i minus 21 times -1. So I have -40 plus 71i plus 21, because the -1 times the -21 makes it a positive 21. So -40i plus 21 gives me -19 plus 71i. So that's what I get for the complex number when I multiply those two together. Okay, in this example, I'm going to multiply 6 minus 7i times 6 plus 7i. So let's go ahead and multiply. So I have 6 times 6 is 36. 6 times 7i is 42i. -7i times 6 is -42i. And -7i times 7i gives me -49i squared. Okay, when we go to combine the middle terms, we notice that they cancel out. So we're left with 36 minus 49 I squared is -1, so I have 36 minus 49 times negative 1. So this is 36 plus 49, which is 85. But it's also, I mean, there's no imaginary part to it. It's a real number. We only have the real part to this number. And how did that happen? Let's go back and look at the problem. Okay, when we look at the problem, we notice that it's in essence like the difference of two squares when we did binomials. But we don't call it the difference of two squares when we're working with complex numbers. We call this, when they're exactly the same except one is a positive and one is a negative, for the imaginary part, we call these the complex conjugate. Okay, we get a complex conjugate when the real part stays the same and the imaginary part, one's positive and one's negative, but they have the same value. And when we multiply them together, we get a real number. Okay, I want to show you something interesting when you actually graph the complex conjugate, number and its conjugate. So in the previous example, I had 6 minus 7i. So if I go to graph that, it's like here's my real axis, which is the horizontal axis, and my vertical axis is imaginary. So I want 6 minus 7i. So I'm going to go 6 to the right, 1, 2, 3, 4, 5, 6, and down 7. 1, 2, 3, 4, 5, 6, 7. So this is the point 6 minus 7i. And the complex conjugate is 6 plus 7i. So we're going to go over 6 and up 1, 2, 3, 4, 5, 6, 7. So I'm going to get 6 plus 7i. And what I notice is that the number and its conjugate are actually a reflection about the real axis, and when we multiply them together, we get a real number. That's pretty cool. Okay, and that finishes this part of the video. Next, we'll do a division of complex numbers. Okay, when we go to divide complex numbers, it's probably going to be written this way and not horizontally. And initially, it's not even obvious that they want you to divide. But just like when we rationalize, when we have radical expressions and we have a radical in the denominator, then we don't leave radicals in the denominator. We don't leave complex numbers or in the denominator. We need to try to get rid of the imaginary part of our number and change it into a real number. From the previous video, we can see that when we multiply a number times its complex conjugate, we get a real number. So that's what we're going to do here. We multiply the 4 minus I times its complex conjugate, which is going to be 4 plus I. And whatever we do to the denominator, we have to do to the numerator. So we're going to multiply times 4 plus I in the numerator. And then we distribute, so we have 2 times 4. So that's going to give us 8. And 2 times I is 2i. 3i times 4 is 12i. And 3i times I gives us 3i squared. All over 4 times 4 is 16. 4 times I is 4, plus 4i. Negative I times 4 is minus 4i. And negative I times I is minus I squared. Okay, if we look at the numerator, and I'm going to combine my like terms, I see 2i and 12i. So I'm going to bring down the 8 plus 14i plus 3i squared all over 16, and my middle terms cancel out. And I have 16 minus I squared. So I know that I squared equals -1. So then here, that'll give me -1. So I'm going to have 8 plus 14i plus 3 times -1 over 16 minus -1. So the numerator is 8 plus 14i minus 3 over 16 plus 1. So this will give me, for my final answer, 8 minus 3 gives me 5 plus 14i over 17. So by multiplying the denominator by its complex conjugate, I end up with a real number in the denominator. So that's the strategy. That's what we're trying to do, is to eliminate I, or in the denominator, change it from a complex number in the denominator to a real number. And the way we do that is we multiply the denominator times its complex conjugate. And if we do that to the denominator, we have to do that to the numerator. And that's what we do with division of complex numbers. And that finishes this video. Thank you.